An underactuated continuum robot using crossing cable configurations. This work explores different cabling methods that can be used in planar cable-driven continuum manipulators. In the traditional cabling method, cables attach to each segment of the manipulator. In our crossing cable method, all the cables run the entire length of the manipulator. Cables are allowed to cross through rigid segments. Soft segments were molded from elastomer. Rigid segments were 3D printed. Later versions included steel pins. M2 screws connected segments together. Fishing line was used for the cables. Results: a crossing cable configuration that closely matches the performance of a traditional cable configuration. This graph shows the workspace, or range of motion, for the traditional cable configuration. The x-axis and y-axes represent the distance in the x and y-axis given in meters. The shaded blue region represents the locations that the end of the manipulator can reach in 1 cm by 1 cm increments. The intensity of the blue represents how many orientations the manipulator can reach for a given location. The orientation is the angle of the end of the manipulator and is divided into 8 evenly distributed bins from 0 to 360 degrees. The spine and control box is drawn onto the graph for clarity. This chart compares the workspace for the traditional cable configuration to a crossing cable configuration. The workspace for the traditional cable configuration is shown in blue in the bottom left corner and matches the graph we just discussed. The workspace for the crossing cable configuration is shown in red in the upper left corner. The crossing cable configuration used 8 cables instead of the 12 needed for the traditional cable configuration. The cabling pattern for the crossing cable configuration is shown to the left of the chart. Note that only 4 cables are shown, but if they are mirrored, you get the 8 cables used. The large chart compares the two workspaces. The areas where there is more red indicates that the crossing cable configuration performed better in those locations, while the blue indicates the traditional cable configuration performed better in those locations. We can see that the crossing cable configuration performed better in the center of the workspace. The traditional cable configuration performed better on the sides of the workspace. Overall, the performances of the two configurations are comparable. Results: flexibility of the cable workspace. By using crossing cables, you can achieve dramatically different workspaces from that of the traditional cable configuration. This can be used to physically limit the workspace of the manipulator, which could be useful for given applications where the user does not want the spine to operate in a given location. Traditionally, this is done in code, but limiting the system physically offers greater safety. Thank you very much for watching, and this has been the Faboratory.